Hi students, in this lecture I will discuss quantum numbers. Topic is quantum numbers. At first I will define two quantum numbers. Listen carefully. Quantum numbers are set of four numbers. Always keep in mind, quantum numbers are set of four numbers, and all four numbers gives details information about electrons in an atom. I am repeating, all four numbers gives details information about electron in its atom. Let's start quantum numbers. First, quantum number defined as topic is quantum numbers. What is quantum numbers? Listen, the set of four numbers, and always keep in mind four numbers. That means types of quantum numbers are four. The set of four numbers which gives all informations, it means details information of electrons in its atom. Clear? Quantum numbers gives all informations of electrons in its atom. Clear? All information means mainly position of electron and energy of electron. All information means position, energy, and all information means orbit of electron. That means name of orbit, orbit number, suborbits of electron. That means name of suborbit and shape of suborbit. Orbitals of electron. Listen, all information means about orbit, suborbit, orbital, and a spin of electron, a spinning motion. And according to this statement, it is clear there are four types of quantum numbers. But mathematically, quantum numbers defined as the set of three numbers which obtain from after solution of Schrodinger wave equation. I am repeating, mathematically quantum number defined as the set of three numbers which obtain from after solution of Schrodinger wave equation. Mathematically, the set of three numbers. Listen, there are four numbers, but mathematically the set of three numbers. The set of three numbers which obtain from after solution of Schrodinger wave equation. Clear? Listen, if in a question it is given how many types of quantum numbers, always keep in mind answer will be four. There are four types of quantum numbers. But if in a question it is given how many types of quantum numbers according to Schrodinger wave equation, then answer will be 3. Again I am repeating, normally quantum numbers types 4, but mathematically or according to Schrodinger wave equation, there are 3 types of quantum numbers. Then question will be, which quantum number could not explain Schrodinger wave equation? Answer is 4th quantum number and name a spin quantum number. Clear? Always keep in mind, for MCQ question, there are 4 types of quantum numbers. How many types of quantum numbers according to Schrodinger wave equation? 3. Question: how much quantum number does not explain from Schrodinger wave equation? Answer 1. And which quantum number does not explain from Schrodinger wave equation? Answer is a spin quantum number. Clear? Types and origin of quantum numbers. Now, name of all 4 types of quantum numbers. Listen, there are 4 types. First, principal quantum number. Second, azimuthal quantum number. Third, magnetic quantum number. Fourth, a spin quantum number. And again, mathematically, there are 3 types of quantum numbers: principal, azimuthal, magnetic. Listen, principal, azimuthal, magnetic, these 3 quantum numbers obtained from Schrodinger wave equation. Fourth, that means a spin quantum number does not obtain from Schrodinger wave equation. Then question will be, why we study a spin quantum number? I will discuss after discussion of magnetic quantum number, why we study a spin quantum number. Clear? Now, one by one, I will discuss each and every quantum number. First, principal quantum number. Listen, principal quantum number. To explain the line spectrum, for MCQ question, always keep in mind, to explain the line spectrum, Niels Bohr introduced concept of principal quantum number from orbit angular momentum concept. Look at the board. To explain line spectrum, one objective for you all. Bohr introduced principal quantum number using concept of orbit angular momentum. There are 3 objective questions will be arise from this statement. First objective: why we study principal quantum number? Answer is to explain line spectrum. Who introduced concept of principal quantum number? Answer will be Niels Bohr. And from which concept principal quantum number introduced? The concept is orbit angular momentum. Clear? I am repeating. Principal quantum number introduced by Bohr for explanation of line spectrum and from the concept of orbit angular momentum. All are MCQ. Now, what is orbit angular momentum? According to Niels Bohr, orbit angular momentum, that means mvr is equal to nh by 2 pi, where m is mass of electron, v is velocity of electron, r is radius of orbit, h is Planck's constant, and n is principal quantum number. That means origin of n is nh by 2 pi, and nh by 2 pi is equal to mvr, where n is principal quantum number. And about n. Value of n always natural number. Always keep in mind. Value of principal quantum number always natural number. That means principal quantum number never negative. Principal quantum number never in fraction. Principal quantum number never zero. Only natural number. Principal quantum number always natural number, and hence value of n is equal to 1, 2, 3, 4, 5 dot dot infinity. Clear? Now I will discuss how many types of information obtained by principal quantum number. Look at both. Topic is principal quantum numbers gives following informations about electron, because we know that quantum numbers gives details information about electron. So principal quantum number gives, point number first, it gives orbit number and name of the orbit. Always keep in mind, principal quantum number gives orbit number and name of the orbit. How to gives orbit number and name of the orbit? Always keep in mind, value of n is equal to orbit number. That means n is principal quantum number and n is equal to orbit number. N is principal quantum number and n is equal to orbit number. And it means when n is equal to 1, that means when principal quantum number 1, it means first orbit. N1, because value of n and orbit number both are equal, n is equal to 1, it is first orbit. And first orbit start from k, name k. So n is equal to 1, first orbit k. N is equal to 2, second orbit L. N is equal to 3, third orbit M. N is equal to 4, fourth orbit N. N is equal to 5, fifth orbit O. N is equal to 6, sixth orbit P. N is equal to 7, seventh orbit Q. Clear? First point, value of n gives orbit number and orbit starts from k. That means n is equal to 1, first orbit, k orbit, n is equal to 2, second orbit, and it is L. Clear? The first point, clear? Now, second point. Listen. Number of orbit. One question for you all. Number of orbits in an atom. If in a question, how much orbits in an atom? Answer will be infinite, not 7. Number of orbits in an atom, answer will be infinite. But if in a question, it is given ki number of known orbits. Number of known orbits. The number of known orbit in an atom, then answer will be 7. K, L, M, N, O, P, Q. Again I am repeating. Number of known orbits, answer 7. K, L, M, N, O, P, Q. But number of orbits in an atom, answer will be 7. Now, second point. Principal quantum number gives maximum electron in orbit, in atomic orbit. Listen. And maximum electron in atomic orbit is equal to 2n square. It is formula for maximum electron in atomic orbit. In MCQ question, which of the following formula gives maximum electron in atomic orbit? Then answer will be 2n square, where n is principal quantum number, and we know that principal quantum number is equal to orbit number. Now one table, listen, k orbit, we know that orbit start from k, and k is first orbit. So for k, n is equal to 1. Maximum electron 2n squared to 2 into 1 square, and 1 square 1 into 2 2. That means in k orbit, maximum electron 2. And when in k orbit maximum electron 2, then it means k may be contain 1 electron. K may be vacant, and hence range in k orbit 0 to 2, because 2 is maximum for k and 0 is minimum. That means k orbit may be vacant. Okay, why k orbit vacant? In case of hydrogen, only 1 electron in 1 atom of hydrogen, and in ground state it present in k orbit. But when energy is supplied to hydrogen atom, then ground state electron jump to upper orbit, excited state, and in this case k orbit may be vacant, and hence range 0 to 2. L, and L is second orbit, n is equal to 2. Formula of maximum electron in atomic orbit 2n square, 2 into 2 square, 4 to the 8. That means maximum electron in L orbit 8, and range will be 0 to 8. Third orbit, n is equal to 3. M orbit 2 into 3 square, 3 square 9 to the 18, and hence maximum electron in third orbit 18, and maximum 18, it means range 0 to 18. N is equal to 4. N orbit 2 into 4 square, it will be 4 square, 16, 16 to the 32. In fourth orbit, maximum electron 32, and range is 0 to 32. Clear? It is point number second. There are 2 points discussed. First point, principal quantum number gives orbit number, name of the orbit, and value of n, and principal quantum number is equal to orbit number. And second point, principal quantum number gives maximum electron in atomic orbit, and always keep in mind formula 2n square for maximum electron in orbit. Now, point number third, it gives size. Always keep in mind size of electronic cloud. Principal quantum number gives size of electronic cloud. Listen, when electron moves in circular path, when electron moves in circular path, the due to due to motion of electron, one path create and one dense part create. Listen, due to circular motion of electrons, one dense line create, one dense circular path create, and this dense circular path is called electronic cloud. Cloud means dense path, and it is created due to motion of electron, and hence called electronic cloud. When n is equal to 1, dense part. When n is equal to 2, bigger size of dense part. When n is equal to 3, more bigger part of dense part, and hence when n increases, size of electronic cloud increases, and when n increases, size of electronic cloud increases. Clear? That means principal quantum number gives size of electronic cloud. Next point. It gives distance of electron from nucleus. Principal quantum number gives distance of electron from nucleus. A statement, as value of n increases, n means principal quantum number, distance of electron from nucleus increases. Look at the board, it is n is equal to 1 first orbit, n is equal to 2 second orbit, n is equal to 3 third orbit, For n orbit, n1, n is equal to 1, r1, n is equal to 2, r2, and n equal to 3, r3. And it is clear, r1 less than r2, r2 less than r3, and as the value of n increases, distance of electron from nucleus increases. Clear? Next, it gives energy of electron in atomic orbit. And always keep in mind, when n increases, energy of electron in atomic orbit increases. For an atom, k orbit या k electron has always less energy than L. L has less energy than M, and energy of electron at infinity will be maximum. At infinity, energy of electron is 0. The maximum value of energy of electron is 0. And in any orbit, electron has negative energy. Point number 4, I am repeating. Principal quantum number gives energy of electron, and as n increases, energy of electron increases. Next, it gives atomic size. Always keep in mind, atomic size. Principal quantum number gives atomic size, and as the value of n, n means principal quantum number, for last electron, always keep in mind, as the value of n for last electron increases, atomic size increases. I am repeating, when a atom A, atom B, A atom has n is equal to 2 for last electron, and B atom has n is equal to 3 for last electron, then obvious size of atom B greater than size of atom A, because when n increases for last electron, atomic size increases. Next point, it gives orbit angular momentum. Look at board. It gives orbit angular momentum, and formula of orbit angular momentum nh by 2 pi. It is also origin of principal quantum number, because principal quantum number obtained from this formula mv r is equal to nh by 2 pi. One question based on orbit angular momentum. Calculate orbit angular momentum for last electron of sodium. Now, we know that sodium has atomic number 11, and configuration of sodium electrons is 2, 8 and 1. Listen. Question is, calculate orbit angular momentum for last electron of sodium. Question is, orbit angular momentum for last electron. The sodium has 11 electrons. Configuration 2, 8, 1 and 1 is last electron. 1 is last. The MBR for last electron of sodium. Listen, MBR is equal to NH by 2 pi. N is orbit number. We know that N is orbit number, principal quantum number. This one is electron, last electron. And this one electron, that is last electron of sodium, reside in third orbit. Reside in third. First orbit, second and third. That means for last electron of sodium, N will be 3. It is electron. And for the electron, N is 3, and hence answer will be 3h by 2 pi. What will be answer? 3h by 2 pi. And always keep in mind, MVR is equal to NH by 2 pi, where N is principal quantum number. If in a question, what will be orbit angular momentum for fifth orbit electron? Answer will be 5h by 2 pi. Clear? Next point. It explained to line spectrum. Already discussed कि principal quantum number explained to line spectrum. If in a question it is given principal quantum number explained to an option line spectrum, fine spectrum, emission spectrum, absorption spectrum, then answer will be line spectrum. Next, it gives number of suborbit in an orbit. Principal quantum number gives suborbits in an orbit. Principal quantum number gives suborbits, and detailed information of suborbit I will discuss in next 2 minutes. It gives number of suborbit in an orbit, and number of suborbit in an orbit is equal to n. Listen, n is principal quantum number, orbit n, suborbits and number of suborbits, name of, listen, orbit number, suborbits and name of suborbit. In an orbit, number of suborbit is equal to 1. In an orbit, number of suborbits is equal to n. That is, in first orbit, number of suborbit 1, second orbit, number of suborbit 2, third orbit, number of suborbit 3, fourth orbit, number of suborbit 4. Look at the board. K orbit. K is first orbit, n is equal to 1, and number of suborbit is equal to n. In K orbit, number of suborbit also be 1, and name of the one suborbit is S. Second, L orbit, n is equal to 2, and we know that number of suborbit in an orbit is equal to n, and hence in second orbit 2 suborbits, and name of the both suborbits are S and P. Listen, first orbit only one suborbit S, second orbit 2 suborbits S and P. Now third orbit, number of suborbit 3 and name are SPD, that is, in third orbit 3 suborbits present, SPD. In fourth orbit, n is equal to 4, and hence number of suborbit is equal to 4, and name is SPDF. In fifth orbit, number of suborbit 5, and name is SPDFG. Clear? Again I am repeating, first orbit only one suborbit S, second orbit 2 suborbits SP, third orbit 3 suborbits SPD, fourth orbit 4 suborbit SPDF, and fifth orbit 5 suborbits SPDFG. Clear? Now last point. It gives, that is, principal quantum number gives number of orbitals. If in your mind it is arises what is orbitals, I will discuss in magnetic quantum number. It gives number of orbital in atomic orbit, and number of orbitals in atomic orbit is equal to n square. Listen, number of orbitals in atomic orbit is equal to n square. Look at both. Orbit KLM, n is equal to 1, 2, 3, 4. Suborbits 1, 2. Suborbits. In first orbit 1 suborbit, second orbit 2 suborbits. I have discussed in previous point. First orbit 1 suborbit, second orbit 2 suborbits SP, third orbit 3 suborbits SPD, and fourth orbit 4 suborbit SPDF. And I will discuss in detail. In magnetic quantum number, S has only one orbital. That means first orbit, one suborbit, one orbital, and formula, the number of orbital n square, that means 1 square. But in second orbit, 2 suborbits, S and P, S has one orbital and P has 3 orbitals. So 3 plus 1, 4, and formula 2 square 4. In third orbit, we know that 3 suborbits, SPD, S has 1 orbital, P has 3 orbitals, and D has 5 orbitals, and number of orbitals 1 plus 3 plus 5 is 9, and formula will be n square, that is 3 square. In fourth orbit, 4 suborbits, SPDF, number of orbitals 4 squared, that means 16. How to 16? Because S has 1 orbital, P has 3. 3 plus 1, 4. D has 5. 4 plus 5, 9. And F has 7 orbitals. 9 plus 7, it is equal to 60. And it is principal quantum number. Now, I will discuss next quantum number, which is azimuthal quantum number. Listen. Principal quantum number explained to line spectrum. I will discuss along with principal and azimuthal. Principal explained to line, but azimuthal quantum number. Second name of azimuthal is secondary quantum number, and it is also called orbital quantum number. I am repeating, azimuthal quantum number, secondary quantum number, orbital quantum number, and it is also called subsidiary quantum number. Subsidiary quantum number. Listen, to explain fine spectrum, I have discussed in principal quantum number. Principal quantum number explained to line spectrum, one objective, and azimuthal quantum number explain fine spectrum, another objective. Sommerfeld, name of scientist, introduced azimuthal quantum number. Principal quantum number introduced Niels Bohr. Azimuthal quantum number introduced Sommerfeld. And now, value of azimuthal quantum number. Listen carefully. Value of azimuthal quantum number always depend upon principal quantum number. Always. Value of L always depend upon value of N. And formula of azimuthal quantum number is value of L is equal to 0 to n minus 1, where n is principal quantum number, but only integer. Value of L never be fraction, but 0 to n minus 1, and n is principal quantum number. Listen, one table for value of n and value of L. Value of n, value of L. L is 0 to n minus 1, only integer, and number of value of L. Listen, value of n is equal to 1. When n is equal to 1, then value of L, 0 to 1 minus 1, that is 0. 0 to n minus 1, and n is 1, so 1 minus 1, 0. When n is equal to 1, L is equal to 0, and it is value of L. But number of value of L, how many value? Then 0 is 1, because it is number of value. When in case of 0, 1, 1 and 2, there are 2 value, 1, 2, 3, 3 value, and hence in first orbit, number of value of L is 1. N equal to 1, value of L 0, number of value of L 1. N is equal to 2, value of L 0, 2, 0, 2 minus 1, and 2 minus 1 is 2 minus 1, that means 1. So 0 to 1. When n is equal to 3, L is equal to 0 to 3 minus 1, 0 to 3 minus 1, that means 0, 1, 2, 0 to 3 minus 1, 0 to 2, 0, 1, 2, and number of value of L is 3. When n is equal to 4, 0 to 4 minus 1, 3, 0 to 3, only integer, 0, 1, 2, 3, and number of value of L, 4. When n equal to 5, n is equal to 5. When n is equal to 5, L is equal to 0 to 5 minus 1, 4, 0 to 0, 1, 2, 3, 4, and number of value of L, 1, 2, 3, 4, 5. Number of value of L are 5. Clear? Value of L is equal to 0 to n minus 1. Next, look at both. Azimuthal quantum number gives following information about electron. Principal quantum number gives orbit number, name of orbit. Now, azimuthal quantum number gives name of suborbit. I am repeating. Principal quantum number, orbit number, name of orbit. Azimuthal quantum number, suborbit. Clear? And always keep in mind, when L is equal to 0, then S-Suborbit. L is equal to 0, S-Suborbit. That is, for any S-Suborbit, 1s, 2s, 3s, for any S, L is azimuthal quantum number, it is fixed for any S-Suborbit. S, L equal to 0. For any P, L is equal to 1. P-Suborbit, either 2P, 3P, 4P, 5P. For any P-Suborbit, L is equal to 1. For any D-Suborbit, L is equal to 2. For any F-Suborbit, L is equal to 3. I am repeating, and you all bits keep in mind, for any S-Suborbit, L is equal to 0. For any P-Suborbit, L is equal to 1. For any D-Suborbit, L is equal to 2. And for any F-Suborbit, L is equal to 3. Next, second point. It gives maximum electron in suborbit. Listen, I have discussed in principal quantum number, the principal quantum number gives maximum electron in orbit, and in orbit maximum electron formula 2n square. In azimuthal quantum number, it gives maximum electron in suborbit. What is difference? Principal quantum number gives maximum electron in orbit, formula 2n square. Azimuthal gives maximum electron in suborbit, formula 2 into 2l plus 1. Very much popular for objective question. Which of the following formula gives maximum electron in suborbit? The formula is 2 into 2l plus 1, and it is also is equal to 4l plus 2. Both will be in option, either 2 into 2l plus 1 or 4l plus 2. 2 into 2l plus 1 is formula for maximum electron in suborbit. Listen, suborbit S, we know that for S, L always 0. Maximum electron 4l plus 2, 4 into 0 plus 2 is equal to 2. And in any S suborbit, maximum electron 2. In any S suborbit, maximum 2. For P suborbit, L is equal to 1. We know that for P, L is equal to 1. Maximum electron 4 into 1 plus 2, 6. That is in any P suborbit, maximum electron 6. D suborbit, we know that for D, L is equal to 2. And formula of maximum electron 4l plus 2, so 4 into 2 plus 2, it will be 10. And always keep in mind, for D suborbit, maximum electron 10. And for F suborbit, for F, L is equal to 3. 4 into 3 plus 2, it is equal to 14. And in F suborbit, maximum electron 14. I am repeating, for any S suborbit, maximum 2. For any P suborbit, maximum 6. For any D suborbit, maximum 10. And for any F suborbit, maximum 14. Next point. It gives shape of electronic cloud. I have discussed in principal quantum number. Principal quantum number gives size of electronic cloud. Clear? But azimuthal gives shape of electronic cloud. Listen, and both are most popular objective question. Size of cloud obtained from principal quantum number. Shape of electronic cloud obtained from azimuthal quantum number. Clear? Now, when L is equal to 0, listen, when L is equal to 0, it is S-Suborbit and shape of cloud is spherical. Always keep in mind, L is equal to 0, S, shape spherical. L is equal to 1, P, shape dumbbell. L is equal to 3, F, shape complex. L is equal to 2, D, shape double dumbbell. Again, L is equal to 0, spherical, L is equal to 1, P, dumbbell, for any P, 2P, 3P, 4P, shape dumbbell. L is equal to 2, double dumbbell, D-Suborbit, L equal to 3, F, and complex, that means complicated. Now, what is difference between, listen, what is difference between 2P, 3P and 4P? Listen, all are P and P has dumbbell shape. That means 2P, 3P, 4P has dumbbell shape. But how to identify which is 2P, which is 3P and which is 4P? It depends upon principal quantum number. That means both concept, principal quantum number and azimuthal quantum number used. Listen, 2P, 3P, 4P. Here principal quantum number 2, principal quantum number 3 and principal quantum number 4, azimuthal 1, 1, 1. And when L is equal to 1 dumbbell, that means 2P, 3P, 4P all have dumbbell shape, but size of dumbbell will be different because we know that principal quantum number gives size of electronic cloud and 2P, n is equal to 2, that means dumbbell of P. And in 3P, principal quantum number 2, principal quantum number 3, we know that when principal quantum number increases, size of cloud increases. Clear? So when 3P and L is equal to 1, it has dumbbell shape, but size of dumbbell of 3P always greater than size of dumbbell of 2P, and hence it has also dumbbell shape, but both have different size. Size of this dumbbell greater than this because 3P. In case of 4P, P, it means it has dumbbell shape, but 4P has larger dumbbell size than 3P and 2P, and hence size of 4P is this. Clear? What is difference and how to identify 2P, 3P, 4P? It depends upon size. When P always dumbbell shape, but what is difference between 2P, 3P? It's depend upon size of dumbbell, and it's defined from concept of principal and both azimuthal quantum number. Clear? Next, most important point, it gives orbital angular momentum. I have discussed in principal quantum number orbit angular momentum, and orbit angular momentum is nh by 2 pi. And here it gives orbital angular momentum, and orbital angular momentum symbol capital L is equal to L into L plus 1 into h by 2 pi. L into L plus 1 and h by 2 pi is also called h cross, and it is actually called h phi. H phi. Listen, for any s electron, any s means 1s, 2s, 3s, 4s, for any s. We know that for any s, L always be 0. L always 0 for s electron. Either 1s electron, 2s electron, L 0. And formula of orbital angular momentum is root under L into L plus 1 into h by 2 pi. L is 0 and hence capital L is equal to 0 into 0 plus 1 h by 2 pi, and it is equal to 0. Then always keep in mind, for any s electron or vital angular momentum 0. Again I am repeating, for any s electron or vital angular momentum 0, because formula is root under L into L plus 1 h by 2 pi and L 0, and hence overall term 0. Now next, for any p electron, we know that any p, that means 2p, 3p, 4p, for any p electron L is equal to 1. Yes or no? When L is equal to 1, orbital angular momentum root under 1 into 1 plus 1 into h by 2 pi, root under 2 h by 2 pi, for any p, either 2p, 3p, orbital angular momentum root under 2 into h by 2 pi or root under 2 h phi. Clear? Next, for any d electron, 3d, 4d, 5d, 6d, any d, L is equal to 2. For any d, we know that L is equal to 2. Orbital angular momentum root under L into L plus 1 is h by 2 pi and root under 2 into 2 plus 1 h by 2 pi, and hence after calculation it will be root under 6 into h by 2 pi or root under 6, and h by 2 pi is called h phi. Clear? For any f electron, 4f, 5f, for any f, 4f, 5f, 6f, and for f electron, L is equal to 3. And orbital angular momentum root under 3 into 3 plus 1, that means root under 12 into h by 2 pi, root under 12 h phi. Clear? I am repeating, orbital angular momentum, and most important for your competitive exam, for any s electron, orbital angular momentum 0. For any p electron, for any p, 2p, 3p, for any p electrons, orbital angular momentum or vital angular momentum root under 2 into h by 2 pi. For any f electron, root under 12 into h by 2 pi. For any d electron, root under 6 into h by 2. I am again repeating, for any s electron or vital angular momentum 0. For any p electron, root under 2 into h by 2 pi. For any d electron, root under 6 into h by 2 pi. And for any f electron, root under 12 into h by 2 pi. Now, last point of azimuthal quantum number and most important point. It gives energy of electron in suborbits. I have discussed in principal quantum number, it gives energy in orbit. It gives energy in orbit. When orbit number increases, n increases, energy increases. But azimuthal quantum number gives energy in suborbits. Listen carefully. Energy is equal to n plus L. For poly-electron system, that means which has 2 and more than 2 electrons, energy equal to n plus L. Where n is principal quantum number, L is azimuthal quantum number. There are two parts. Listen, case first. When n plus L are different, when n plus L of two suborbits are different, then very easy. Higher n plus L having higher energy. Listen, when n plus L are different, higher n plus L, higher energy. Example, 4s. 4 is principal quantum number, and for S, L is 0, azimuthal quantum number. The n plus L, 4 plus 0, 4. 3d, 3 is principal quantum number, and for D, L is equal to 2, so 3 plus 2 is equal to 5. 4s, n plus L 4, 3d, n plus L 5, and when n plus L are different, in this case, n plus L are different, 4 and 5, and very simple, higher n plus L, higher energy, and hence 4s and 3d has higher energy than 4s because higher n plus L. Now, second example, 6s. In 6s, principal quantum number 6. For S, azimuthal 0. For any S, L is equal to 0. 6, n is equal to 0, L is equal to 0. For 6s, n plus l, 6 plus 0 is equal to 6. For 4f, n is equal to 4. And for f, l is equal to 3. So 4 plus 3 is equal to 7. In case of 6s and 4f, n plus l 6, 4f, n plus l 7, and we know that when n plus l are different, higher n plus l higher energy, and hence 4f has higher energy than 6s. Clear? I am repeating, when n plus l are different, very simple, higher n plus l higher energy. Case second, when n plus l value of two suborbits are equal. When n plus l will be equal, then higher n having higher energy. Listen, then higher n, when n plus l are equal, then higher n having higher energy. Example, 3D, 4P, 5S. In case of 3D, n is equal to 3, and for D, l is equal to 2. 4P, n is equal to 4, and for P, l is equal to 1. 5S, n is equal to 5, l is equal to 0. In each cases, n plus l, 3 plus 2, 4 plus 1, 5 plus 0, all have 5. But when n plus l are equal, then higher n higher energy, and hence 3D is lesser than 4P and 4P lesser than 5S. That is, in between 5S, 4P, 3D, 5S has higher energy than 4P and 4P has higher energy than 3D, because n increases, n3, 4, 5. When n plus l are equal, n increases, energy increases. Second example, 4D, 5P, 6S. 4D, 4 plus 2, 6. 5 plus 1, 6. 6 plus 0, 6. All have equal n plus l. But when n plus are equal, n increases, energy increases. In case of 4D, n is equal to 4, 5P and 5, 6S and 6, and hence 4D lesser than 5P and 5P lesser than 6S. One important term, n plus l rule only applicable for poly-electron system, not applicable for hydrogen atom and like hydrogen atom. In hydrogen and like hydrogen atom, listen, n plus l rule is not applicable for hydrogen, only applicable for poly. That means the species which have 2 and more than 2 electrons. In hydrogen atom, energy of electrons depend upon only principal quantum number. As n increases, energy increases. Example, in hydrogen atom, 1s less than 2s. But 2s, 2p are equal, because in 2s, 2p, principal quantum number same. 2s, 2p, principal quantum number same. And when principal quantum number same, in hydrogen atom, energy is same. 3s, 3p, 3d. 3s, 3p, 3d. Then 2p, 3s has high energy. But between 3s, 3p, 3d, all have equal energy. Because when n increases, energy increases, but in case of 3s, 3p, 3d, each has same value of principal quantum number and same energy. And in case of 4s and 3d, 4s higher n and 3d lower n. But n plus l rule, 3 plus 2, 4 plus 0, 3d has higher n plus l. But in hydrogen atom, n plus l rule not applicable, and hence 4s has high energy than 3d, and between 4s, 4p, 4d, 4f all have equal. Listen, in hydrogen atom, 3d less than 4s. In multi-electron species, 3d greater than 4s. Because in multi-electron, N plus L rule applicable, but in hydrogen N plus L rule not applicable, and hence 3D less than 4s in hydrogen and 3D greater than 4s in case of poly-electron system. There are two quantum numbers, principal and azimuthal quantum number. In next lecture, I will discuss about two quantum numbers, magnetic and spin quantum number. Thank you.